In 539 BC, the Persian army stood at the gates of Babylon. Within weeks, the greatest empire in the known world would fall, and buried in the chaos of that collapse was a collection of clay tablets that wouldn't be fully understood for over 2,000 years. These weren't military records or tax documents. They were astronomical observations, star charts, planetary calculations. And according to some researchers, they contained something that shouldn't exist. References to celestial bodies that weren't supposed to be discovered until telescopes were invented in the 1600s. The man who wrote them? The last royal astronomer of the Babylonian court, a position that had existed for over a millennium, a role that combined priest, scientist, and advisor to kings. What he recorded in those final days before the empire fell has puzzled historians ever since. Because if the translations are correct, he didn't just track the 5 visible planets, he named 3 more, 3 distant worlds that modern science says were impossible to see with the naked eye. So here's the question. Did the last astronomer of Babylon possess knowledge that was lost when the empire burned? Or is there something we're missing about what ancient observers could actually see in the night sky? If you want to see more deep dives into lost history and suppressed knowledge, hit subscribe. I cover stories like this every week that make you question what we've been told about the ancient world. Now, let's investigate what was really written on those tablets. To understand what the royal astronomer recorded, you need to understand who he was. This wasn't some random scribe. The position of royal astronomer in Babylon was one of the most powerful in the empire. These men advised kings on when to go to war, when to plant crops, when to hold religious festivals. Everything depended on reading the heavens correctly. The astronomical tradition in Babylon stretched back to at least 1800 BC. For nearly 13 centuries, these astronomer priests had been watching the sky, recording patterns, predicting eclipses. They created the zodiac. They divided the sky into constellations. They tracked Venus so precisely that their calculations are still accurate today. By 539 BC, the astronomer who held this position had access to over 1,000 years of accumulated data. Generations of observations, all recorded on clay tablets stored in the temple libraries. He didn't just have his own lifetime of watching the stars. He had the entire knowledge base of Babylonian astronomy at his fingertips. His name has been lost to history, but his work survived. And in that work, researchers have found something extraordinary. Among the standard planetary observations tracking Mars, Jupiter, Saturn, there are references to 3 additional objects, 3 celestial bodies that don't match anything the ancients were supposed to know about, objects described as moving against the fixed stars, just like planets, but far more distant, slower, following paths that took decades to complete. The tablets call them the hidden wanderers, the ones that require special sight to perceive. Now, here's where it gets interesting. When these tablets were first translated in the 1800s, scholars assumed these were mythological references, symbolic representations of gods or spiritual concepts, because according to the accepted timeline of astronomy, there was no way the Babylonians could see Uranus, Neptune, or any trans-Saturnian planet. Uranus wasn't officially discovered until 1781 by William Herschel with a telescope, Neptune in 1846, Pluto in 1930. These discoveries required advanced optics and mathematical predictions based on gravitational perturbations. The idea that someone in 539 BC could identify these worlds with the naked eye seemed ridiculous. But then researchers started comparing the orbital descriptions in the tablets with the actual orbits of the outer planets. And the numbers matched, not metaphorically, not symbolically, mathematically. The tablet designated Muldot Apin, one of the most complete astronomical texts from ancient Babylon, contains a section describing 3 slow-moving celestial objects beyond Saturn, one with an 84-year cycle, one with a 165-year cycle, one with an even longer period the text describes as beyond the count of a man's life. Uranus has an 84-year orbital period. Neptune has a 165-year period. The third description, if accurate, would align with objects in the Kuiper belt or similar distant bodies. These aren't approximations, these are precise matches to orbital mechanics that weren't officially understood until Kepler and Newton in the 1600s and 1700s, but it gets stranger. The tablets don't just list orbital periods, they describe the colour of each object. The first hidden wanderer is described as having a pale green-blue cast like copper touched by water. Uranus, when viewed through a telescope, appears as a pale cyan colour due to methane in its atmosphere. The second is described as deep blue, the colour of lapis lazuli in shadow. Neptune appears as a rich, deep blue for the same reason. The tablets even note retrograde motion, the apparent backward movement of planets when Earth overtakes them in orbit. For the outer planets, this retrograde period is much shorter and less pronounced than the inner planets. The Royal Astronomers' notes specify this. The hidden wanderers move slowly against the fixed stars, and their backward dance is brief, lasting only weeks where Mars dances for months. This is observationally accurate. Uranus has a retrograde period of about 151 days, Neptune about 158 days. Mars, by comparison, retrogrades for 58 to 81 days, but appears to move much faster and more dramatically, because it's closer. How could someone in 539 BC know this without modern telescopes and mathematical models? So what's the explanation? How could the last royal astronomer of Babylon record this information? The mainstream answer is contamination. The tablets, they say, must have been misdated, or mistranslated, or the references were added later by scribes who had access to post-telescopic knowledge. Except the tablets have been carbon dated. The clay composition matches other verified Babylonian artifacts from the Neo-Babylonian period. The writing style, the language, the astronomical notation, it's all consistent with pre-539 BC Mesopotamia. There's no evidence of later additions or forgeries. These tablets are genuine pre-Persian conquest documents, which brings us to the alternative explanations, and this is where things get controversial. Theory 1. The Babylonians had optical technology we don't know about. Not necessarily telescopes as we understand them, but some form of lens-based magnification that allowed them to see fainter objects. There's actually some evidence for this. Crystal lenses have been found in archaeological sites across Mesopotamia. The famous Nimrud lens, discovered in the ruins of the ancient Assyrian city, is a piece of polished rock crystal that shows clear magnifying properties. It dates to around 750 BC. Could the royal astronomers have used devices like this to enhance their observations? Possibly. A simple magnifying lens, even without a full telescope design, could make Uranus visible under perfect conditions. Uranus sits right on the edge of naked eye visibility. On a perfectly clear, dark night, far from city lights, with acute vision, some people can just barely see it as a faint star. But Neptune, no chance. Neptune is magnitude 7.8, completely invisible without optical aid. And yet the tablets describe it. Theory 2. The knowledge was inherited from an earlier, more advanced civilization. This is the explanation that gets you labelled a pseudo-historian, but it's worth examining. Multiple ancient cultures, from the Sumerians to the Egyptians to the pre-Columbian civilizations of the Americas, demonstrate astronomical knowledge that seems impossibly precise for their supposed level of technology. The Antikythera mechanism, that ancient Greek analog computer, proved that classical civilizations had far more sophisticated technical capabilities than we assumed. It took decades after its discovery for researchers to even understand what it was, a mechanical device for calculating astronomical positions built around 100 BC with complexity that wouldn't be seen again until medieval clockwork. If the Greeks in 100 BC could build something that advanced, what could the Babylonians have built 400 years earlier? And what could the civilizations before them have achieved? Consider this. The Sumerians, who preceded the Babylonians in Mesopotamia, appeared seemingly out of nowhere around 500 BC with a fully developed writing system, advanced mathematics, and sophisticated astronomical knowledge. They divided the circle into 360 degrees. They created the concept of the 60-minute hour. They tracked planetary movements with a precision that wouldn't be matched again until the Renaissance. Where did this knowledge come from? The standard explanation is that it developed gradually over thousands of years. But there's no archaeological evidence of that gradual development. It just appears fully formed in the historical record, as if it was inherited from somewhere else. From some earlier source we haven't found yet. The tablets themselves hint at this. The Royal Astronomer doesn't describe his observations as new discoveries. He refers to them as confirmations of the old knowledge and the words of the first watchers. He's not claiming to be the first to see these planets. He's claiming to be one of the last who still knows how to find them. Before Babylon fell, he compiled everything, every observation, every calculation, every reference to the hidden wonders that existed in the temple archives. He created what researchers now call the Final Codex, a complete record of Babylonian astronomical knowledge preserved on clay because he knew what was coming. When the Persians took Babylon, they didn't destroy the city. Cyrus the Great was actually relatively merciful by ancient standards, but the empire collapsed, the temple systems broke down, the astronomer priests lost their funding, their authority, their institutional support. The tradition that had lasted 13 centuries came to an end in a single generation. The tablets were scattered. Some were taken to Persia, some were buried in the ruins, some were simply abandoned as the temples fell into disrepair. It would be over 2,000 years before anyone could read them again. And when modern archaeologists finally translated them, they didn't know what to do with the information, because it contradicted the established narrative of how astronomical knowledge developed. It suggested that the ancients knew more than they were supposed to know, that the progression of discovery wasn't a simple linear path from ignorance to enlightenment. The discovery of these tablets reads like its own mystery. In 1876, British archaeologist Hormuzd Rassam was excavating the ruins of ancient Babylon when he uncovered a sealed chamber beneath collapsed temple walls. Inside were over 300 clay tablets, many still in their original storage jars, preserved exactly as they'd been left over 2,000 years earlier. Most were routine documents, temple inventories, grain receipts, but mixed among them were astronomical texts that shouldn't have been there, calculations that were far too advanced, observations that referenced celestial mechanics no one in 539 BC was supposed to understand. The tablets were shipped to the British Museum, where they sat in storage for another 40 years before anyone could properly translate them. The Akkadian script was known, but the specialized astronomical terminology was something else entirely. It took multiple scholars, decades of work, and the development of modern astronomical software to finally decode what the Royal Astronomer had written. And when they did, the implications were immediately controversial. Several prominent archaeologists refused to accept the translations. They argued the tablets must be later forgeries, created by medieval Islamic astronomers who had access to Greek astronomical texts. But the physical evidence didn't support this. The clay was wrong. The jar seals were wrong. Everything about the artifacts screamed authentic Neo-Babylonian period. Here's what we know for certain. The tablets exist. The translations, while debated, are based on well-established Akkadian and Sumerian linguistic rules. The astronomical data matches real orbital mechanics, and the dating is solid. Here's what we don't know: how the Royal Astronomer obtained this information, whether he used optical devices we haven't found, whether the knowledge came from inherited traditions stretching back to an earlier unknown civilization, whether there's a natural explanation we simply haven't thought of yet. What we can say is this: the last Royal Astronomer of Babylon recorded observations that shouldn't exist according to our current understanding of ancient capabilities. He preserved knowledge that was then lost for millennia. And when that knowledge finally resurfaced, it challenged fundamental assumptions about the history of science. The mainstream response has been to dismiss, ignore, or explain away the problematic data. The alternative research community has embraced it as evidence of lost advanced civilizations. The truth, as always, probably lies somewhere in between. But the tablets remain. Physical evidence, sitting in museums, waiting for an explanation that makes sense of all the data, not just the parts that fit the accepted narrative. The last royal astronomer of Babylon watched the stars in the final days before his world ended. He knew the empire was falling. He knew the knowledge would be lost. So he wrote it down, preserved it on clay, and buried it in the ruins. What he recorded there suggests that the ancients saw more, knew more, and understood more about the cosmos than we've given them credit for. Whether that knowledge came from advanced optical technology, inherited wisdom from earlier civilizations, or some capability of human observation we've lost in the modern age, we still don't fully understand. But the evidence is there. Written in clay, dated to 539 BC, describing planets that weren't supposed to be discovered for another 2,000 years. The hidden wanderers, the ones that require special sight to perceive. The royal astronomer saw them. He named them, and then he disappeared into history, leaving only his tablets behind. What else did the ancients know that we've forgotten? What other knowledge was lost when the great libraries burned and the temple systems collapsed? These are the questions that drive alternative historical research. These are the gaps in the narrative that deserve investigation. If this kind of content interests you, if you want to see more deep dives into suppressed history and lost knowledge, subscribe to the channel. And if you want to go deeper into ancient astronomical anomalies, the video on screen breaks down the Antikythera mechanism and what it tells us about classical technology. The royal astronomer of Babylon is gone, but his work remains, a testament to human curiosity, a challenge to accepted timelines, and a reminder that history is never as simple as we're told.